This video goes over the solutions for the vector addition and subtraction guided practice assignment. I've just set up my paper to have the title, and we're going to start with part 1, the combining vectors section. These vectors, the directions are north, south, east, and west, so just in case you need it, you can draw a compass rose up at the top. So we have north, south, east, and west. For number 1, I'm using this combination here, so I'm calculating A plus B vectors. A is 35 kilometers north. Since I'm not drawing these to scale, I am going to label them. So that's the 35 kilometers north, and then B is 15 kilometers south. When I add them together, first I have to look at the directions of the arrows. So they're going opposite directions. I can think of this as I'm finding the difference. Because they're going opposite directions, I can't combine them like I would for addition. So the difference between 35 and 15 kilometers would be 20 kilometers. And since the number on the north vector is greater than the number on the southern vector, I know that this is going to continue to go north. So then I just draw in my arrow. Since they're going opposite directions, you could have approached this as a subtraction problem. Either way, you come out with the same answer. It's still going to be going north, and it's still 20 kilometers. I just consider them to kind of all be addition because they're being combined. But I remember that since they're opposite, in my head, I'm subtracting the numbers. For number 2, I'm adding vector A and C. This was A and B. So again, A is 35 kilometers north, and C is 20 kilometers east. When I add these together, since they are going in perpendicular directions, I have to draw them nose to tail. So first I had the northern vector and then the eastern vector. To figure out the displacement, if I connect these diagonally, I can figure out what this value is here. So this vector was 35 and this vector was 20. I can figure out x using the Pythagorean theorem. And so when I do this out, I get that x is 40.31 equal to x. The top of your paper says please round your answers to 2 decimal places. So you can leave it at 40.31x. This would tell me that the resultant vector, which is 40.31, this would be kilometers, and it's going in a northeastern direction. For number 3, I'm combining vectors A and D. A is 35 kilometers north, and D is 40 kilometers west. When I combine these, since they're not parallel, I have to do nose to tail again. So I have north and west. Just labeling with their numbers. And again, I can use the Pythagorean theorem to find out what x is. So then my resultant component, or my resultant vector, sorry, is 53.15 kilometers, and it's in the northwest direction. I'll do one more of these, maybe something different than with A. So number 4 has B plus C. Vector B is 15 kilometers south. And C is 20 kilometers east. I have to draw these nose to tail. And then I can figure out what X is. So X is considered the resultant vector. I have 15 squared plus 20 squared equals X squared. So then X equals 25 kilometers, and it's in the southeast direction. I think I may have made a mistake up here. Let me just double check this one. No, it was correct actually. Okay, so I've done 4 of those from part 1. Basically, we follow the same pattern every single time. If you have 2 vectors that are going in opposite directions, we can combine them with simple addition or subtraction. If they're going the same direction, I don't think we have any that are going the same direction. But if we had A plus A, we would have a 35 kilometer vector going in the north direction, as well as the second one. When we combine those, we would get a vector that is 70 kilometers and in the north direction, because 35 plus 35 is 70. So if they are going in the same direction, combine them. If they are going in opposite directions, like in number 1, we still say you combine them, but it's a subtraction problem. And then if the vectors are perpendicular, then you have to use the Pythagorean theorem. So I've done 4. That would mean you have 2 more you have to do on your own. I'm going to just pause the video for a second and get set up for part 2. I've already done, I think, the first 2 problems in the other video, but there was no video, so I'll just go through those kind of quickly, and then I'll do 2 or 3 more, and then you can do the rest. So for number 1, we have a plane heads east with a velocity of 52 meters per second through a 12 meter per second crosswind blowing the plane south. Find the magnitude and direction of the plane's resultant velocity. So again, I'm going to draw that compass rose. And so we have the plane heading east. So there's my vector pointing east. The magnitude for this vector is 52 meters per second. I will label it east just so we can keep track of the direction. And then we're told that there's a crosswind of blowing the plane south. So that vector will point down, and a 12 meter per second crosswind. Since these are perpendicular, I have to line them up nose to tail. Sorry, no, I did that right. I thought I had to put south first. So we have the eastern vector and then the southern vector. Their values are 52 and 12. So just like in part 1, we'll use the Pythagorean theorem to figure out what the value of that is. I did get rid of the units because I honestly just don't feel like writing them over and over. The unit at the end will still be meters per second. So I'm just going to tack that on at the end. And again, I'm only rounding to the nearest 2 decimal places, so going out to 0.36 and then rounding up because the next value is a 6. So x ends up being 53.37 meters per second, and judging by my dotted line, this is in the southeast direction. So there's number 1. Number 2 says a mountain climbing expedition establishes a base camp and 2 intermediate camps, A and B. Camp A is 11,200 meters east of and 3,200 meters above the base camp. Camp B is 8,400 meters east of and 1,700 meters higher than Camp A. So we need to determine the displacement between base camp and Camp B. I'm going to draw a diagram a little bit further down my page so I can make sure I have plenty of room. If I consider this dot base camp, I'm going to draw everything that I read in that problem. So we have base camp. Camp A is 11,200 meters east. So I'm going to go that way and label this 11,200 meters east. And 3,200 meters above. Above is the same in terms of direction as north. So 3,200 meters north. Obviously these are not drawn to scale. I would be here all day measuring it out, so I'm just not drawing them to scale. This point would be Camp A. Then I'm told Camp B is 8,400 meters east of Camp A and 1,700 meters higher. So this is Camp B. Question was, determine the displacement between base camp and Camp B. Since this is not drawn to scale, I can't just rely on measuring something, but what I'm trying to figure out is the distance that this dotted line covers. I'm going to redraw this triangle, or these 2 triangles, one big triangle. So if I think about the eastern vectors, I can combine the 2 eastern vectors from the problem. So along the bottom of the triangle, I would have a vector that is a value of 11,200 meters, and another one that has a value of the 8,400 meters. Then going north, I have one that is 3,200 meters, and one that is 1,700 meters. Okay, so now that they're lined up nicely, that dotted line I have looks a little better. So again, it's just the Pythagorean theorem. When I combine these 2, I get 19,600 meters. When I combine these 2, I get 4,900 meters. And I'll put the directions in there. So for x, I'll have 19,600 meters squared plus 4,900 meters squared equals x squared. I just happened to write the units in here on the previous problems, like up here. I didn't rewrite the units. It's fine if you don't. Just make sure you tack them on at the end. And I certainly don't know these values. Since I'm using the calculator on my computer, I can't really just keep going. It's not going to cooperate, so I have to write them out, but you probably don't have to. So I find that x equals 20,203.22 meters, and base camp to camp B is a northeastern path. So 20,203.22 meters northeast. So that one was a little tedious, I suppose, but still pretty easy once you arrange the vectors in the right way. So I'll do maybe two more. Number 3 says, I went for a walk the other day. I went 4 streets east, which was 0.80 miles, then 10 streets south, which was 1.2 miles, then 1 street west, 0.20 miles, and finally 8 streets north, 0.40 miles. What was my resultant displacement? So let's see, I'm going to start here. So this is where I started my walk. I'm going to go 4 streets east. This is 0.08 miles. Then 10 streets south. This was 1.20 miles. Then I went 0.2 miles west and 0.40 miles north. I should label all of my directions as well. Okay, so displacement would be the distance from where I started and where I ended. I'm going to pause the video and draw something, and then I'll come back. Okay, I've come back. What I've done is separated out each of the vectors so we can look at them individually. So originally I drew a diagram to show how the vectors would appear during the walk, and I've just separated them out so that we can combine them individually, kind of how we combined them up here. For these, I have, again, my eastern vector and my western vector, and then this is southern and northern. I should remind you they are not drawn to scale, but we can still combine the horizontal vectors like east and west, and then the vertical vectors like north and south. So for the horizontal portion of this walk, I have my eastern vector of 0.8 miles, and I'm going to combine this with my 0.2 miles west. So they're going to opposite directions, so they partially cancel each other out. This is like a subtraction problem. So if I think of the 0.8 and it being minus the 0.2, this would give me a vector that is equal to 0.6 miles. And since the eastern vector was originally the larger vector, this is going to be an eastern vector, and the direction will be pointing that way since it's east. Now for north and south, my southern vector was 1.20 miles south, and I'm adding the northern vector of 0.40 miles. Again, since these are going opposite directions, we can think of this as a subtraction problem. So 1.2 minus 0.4 would be 0.8 miles. And since the southern vector was originally larger, this is going to continue to be in the southern direction, so my arrow would point down. Now I'm left with just these two vectors, and I can draw my triangle. So from this dot to the end of the walk would be 0.6 miles east, and then 0.8 miles south. So that would be this walk here, and then we're going to find out what that diagonal line was. So if I connect here, this will be x, and I have 0.6 squared plus 0.8 squared equals x squared. I don't really know why I have to check that, but I just feel like I have to. When we add them together and find the square root, oops, sorry. No, that is right. So when I add these together, I get 1.0. The square root of that would just be 1. So essentially what this is saying is I've gone about 1 mile from the start to the finish.